In a mere 10 years, the world as we know it will be subtly, yet profoundly, reshaped by the quiet revolution of quantum physics. Far from the realm of abstract theories and esoteric laboratories, quantum phenomena are poised to transition from scientific marvels to indispensable tools, weaving themselves into the very fabric of our technological landscape. It won't be a sudden, dramatic overhaul, but rather a persistent, transformative tide, pushing the boundaries of what's currently possible and unlocking entirely new capabilities across diverse fields. Imagine a future where the most intractable problems that plagued classical computers, from designing new life-saving drugs to optimizing global logistics, become solvable. By 2035, while general-purpose quantum computers won't be in every home, they will be increasingly accessible via the cloud, serving as powerful accelerators for governments, large corporations, and research institutions. These early quantum machines, still in their adolescence, will begin to tackle highly complex simulations, allowing scientists to model molecular interactions with unprecedented accuracy, leading to breakthroughs in materials science and drug discovery. The path to personalized medicine will accelerate, as quantum simulations aid in understanding complex biological systems, potentially revolutionizing how we treat diseases and develop therapies. Beyond computation, the quantum realm will dramatically enhance our ability to sense and communicate. Quantum sensors, leveraging the exquisite sensitivity of quantum particles, will become commonplace in specialized applications. Think of magnetometers so precise they can detect the faintest neural signals in the brain for advanced medical diagnostics, or inertial navigation systems that are impervious to GPS jamming, guiding autonomous vehicles and aircraft with unparalleled accuracy, even in challenging environments like underground tunnels or underwater. These sensors will also be instrumental in fundamental research, allowing us to probe the universe with new eyes, potentially even shedding light on the quantum nature of gravity itself. The seemingly impregnable digital fortresses we rely on today for secure communications will face an existential threat from the looming power of quantum computers. However, the quantum world also offers its own shield, quantum cryptography. By 2035, we'll see a significant shift towards post-quantum cryptography, new encryption algorithms designed to withstand attacks from future quantum machines. More intriguingly, rudimentary forms of quantum communication networks, built on the principles of entanglement, will begin to emerge. While a full-fledged quantum internet might still be further off, these initial networks will offer truly unhackable communication channels for highly sensitive data, laying the groundwork for a new era of secure information exchange that defies classical eavesdropping. The energy sector will also feel the quantum ripple. The principles of quantum thermodynamics are already being explored to design ultra-efficient quantum engines and quantum refrigerators, potentially leading to radical improvements in energy consumption and waste. Furthermore, the concept of quantum batteries, which store energy in quantum states, could offer faster charging and more efficient discharge cycles, impacting everything from consumer electronics to large-scale energy storage solutions. In essence, by 2035, quantum physics will have moved beyond theoretical curiosity to become a foundational pillar of innovation. It will not replace classical technologies but rather augment them, offering solutions to problems that were once deemed impossible. The world will become a more precise, more connected, and more profoundly understood place, all thanks to the strange and wonderful rules of the quantum universe. And this transformation won't be confined to the realm of high-tech industries. Consider the humble smart city. By 2035, quantum-enhanced sensors could be embedded in infrastructure, monitoring everything from traffic flow with unprecedented accuracy to detecting minute structural weaknesses in bridges and buildings, preempting disasters and optimizing maintenance schedules. Urban planning will become more intelligent, as quantum algorithms process vast datasets to create more efficient public transport networks, manage energy consumption, and even predict localized climate patterns, allowing cities to adapt and thrive in a changing world. In finance, the implications are equally profound. Quantum algorithms will revolutionize risk assessment, enabling financial institutions to model complex market dynamics and predict volatility with far greater precision. This could lead to more stable markets, reducing the likelihood of economic crises and opening up new avenues for investment strategies. Furthermore, quantum machine learning, still in its nascent stages, will empower AI systems with the ability to discern patterns in data that are invisible to classical algorithms, leading to breakthroughs in fraud detection, algorithmic trading, and personalized financial advice. The very way we interact with information and the world around us will also evolve. Imagine augmented reality systems that are so responsive and seamless, they feel indistinguishable from reality, powered by compact quantum processors handling immense data streams in real time. Or consider quantum imaging, offering resolutions and sensitivities far beyond what's currently achievable, allowing us to see through dense materials, analyze microscopic structures, and even peer into the human body with unprecedented detail for early disease detection. However, this quantum leap isn't without its challenges. The development of robust, fault-tolerant quantum computers remains a significant hurdle. Furthermore, as quantum technologies mature, there will be a pressing need for a new generation of skilled professionals, quantum engineers, quantum software developers, and quantum data scientists, to harness their full potential. This will necessitate a paradigm shift in education, integrating quantum principles into curricula at various levels. Ultimately, the quantum revolution by 2035 will be characterized by a growing symbiosis between classical and quantum technologies. Quantum systems won't replace everything, but rather act as specialized, powerful complements, tackling the problems that classical systems simply cannot. The world will become a more intelligent, efficient, and interconnected place, driven by the subtle yet powerful forces of the quantum realm, continuously pushing the boundaries of human ingenuity. The future, it seems, is not just digital, but also deeply, intricately quantum. As we venture deeper into this quantum-infused future, the impact will extend even to our understanding of the universe itself. Quantum cosmology and quantum gravity, currently theoretical frontiers, may see tangible advances thanks to enhanced quantum computing capabilities. Simulating the early universe or the behavior of black holes at a quantum level could unlock secrets that have eluded physicists for centuries, fundamentally altering our perception of space, time, and matter. We might finally begin to bridge the gap between Einstein's general relativity and quantum mechanics, leading to a unified theory that describes all forces of nature. The integration of quantum principles into fields like artificial intelligence will also accelerate, moving beyond current machine learning paradigms. Imagine AI systems capable of processing information in fundamentally new ways, exploring vast solution spaces for complex problems with unprecedented efficiency. This could lead to genuinely intelligent robots and autonomous systems that learn and adapt with a level of sophistication previously confined to science fiction. From optimizing traffic flow in real time to personalized educational programs that adapt to individual learning styles, the applications of quantum-enhanced AI will be truly transformative. Furthermore, the very nature of cybersecurity will undergo a radical metamorphosis. The ongoing quantum arms race will necessitate a constant evolution of cryptographic protocols. While quantum computers pose a threat to current encryption standards, the development of robust quantum key distribution (QKD) systems will become paramount for safeguarding critical infrastructure, financial transactions, and national security communications. This means a shift towards quantum-resistant algorithms and, eventually, a global network underpinned by inherently secure quantum communication channels. The ethical and societal implications of this quantum leap will also become a more pressing concern. As quantum technologies become more powerful, questions around their responsible development and deployment will intensify. Debates around data privacy in a world of quantum sensors, the potential for quantum-enhanced surveillance, and the equitable distribution of these transformative technologies will be at the forefront. Ensuring that the benefits of the quantum revolution are shared broadly and that these powerful tools are used for the betterment of humanity will be a critical challenge. By 2035, the world won't be a different planet, but it will certainly be a radically different experience. The subtle hum of quantum processes will underpin much of our technological infrastructure, from the devices in our pockets to the global networks connecting us. We'll live in a world that is more precisely measured, more securely connected, and more intelligently managed, all thanks to the strange and beautiful rules of the quantum realm. The future, in its essence, is becoming undeniably quantum. The ripple effects of quantum physics will not merely refine existing technologies, they will catalyze the emergence of entirely new fields, leading to unforeseen industries and job markets. Consider the realm of quantum biology, a nascent field that will likely blossom by 2035. Researchers are already exploring how quantum phenomena might play a role in fundamental biological processes like photosynthesis and enzyme catalysis. A deeper understanding of these quantum effects could unlock revolutionary approaches to biotechnology, leading to more efficient energy solutions or even entirely new methods for medical intervention. Imagine a future where diseases are not just treated, but their quantum origins are understood and manipulated. Furthermore, the advent of quantum materials will continue to accelerate. These are materials designed at the atomic and subatomic level to exhibit extraordinary properties, such as superconductivity at room temperature or enhanced magnetic capabilities. By 2035, we could see the first commercial applications of these materials in energy transmission, computing, and even transportation, leading to vastly more efficient and powerful devices. The ability to precisely manipulate matter at its most fundamental level opens up a universe of possibilities for designing materials with bespoke functionalities. The very concept of simulation will be redefined. Beyond traditional scientific and engineering simulations, quantum computers will enable hyperrealistic virtual environments for training, design, and even entertainment. Imagine virtual reality experiences so immersive that they are indistinguishable from reality, or complex engineering projects simulated with such fidelity that physical prototypes become largely obsolete. This could revolutionize industries from aerospace to entertainment, drastically reducing development costs and accelerating innovation cycles. However, as quantum technologies proliferate, so too will the need for quantum literacy across society. Understanding the basic principles of quantum mechanics will become increasingly important, not just for scientists and engineers, but for policymakers, ethicists, and even the general public. Educating future generations about this paradigm shift will be crucial to harnessing its full potential responsibly and ethically. By 2035, the quantum revolution will have moved beyond the realm of specialized laboratories and into the everyday fabric of our lives. It will be the invisible force powering our most advanced technologies, securing our communications, and pushing the boundaries of human knowledge. The world we inhabit will be profoundly shaped by the strange and beautiful rules of the quantum realm, promising a future that is not just technologically advanced, but fundamentally reimagined. By 2035, the quantum wave will have swept through almost every sector, subtly yet profoundly altering the landscape of our daily lives. Think about environmental monitoring and climate change mitigation. Quantum sensors, with their unparalleled precision, will be deployed globally to track greenhouse gas emissions with unprecedented accuracy, identify subtle shifts in ocean currents, and monitor the health of ecosystems. This real-time, high-fidelity data will empower scientists and policymakers to make more informed decisions, leading to more effective strategies for combating climate change and preserving biodiversity. Imagine knowing the precise carbon footprint of every industrial process, enabling targeted interventions and inspiring a new era of environmental responsibility. The very concept of manufacturing and industrial design will undergo a transformation. Quantum computing will enable the simulation of complex molecular structures for advanced materials, leading to the creation of lighter, stronger, and more energy-efficient components for everything from aircraft to consumer electronics. This will drastically reduce waste and energy consumption in production. Furthermore, quantum-enhanced robotics could lead to highly autonomous manufacturing facilities capable of adapting to changing demands with remarkable agility, pushing us closer to a truly circular economy. Even our entertainment and artistic experiences will feel the quantum touch. Imagine interactive media where quantum-enhanced AI generates realistic, responsive environments that adapt to individual user input in real time, blurring the lines between the digital and physical. The creation of complex, multi-layered narratives and virtual worlds will become far more accessible to creators, fostering an explosion of unprecedented artistic expression. Quantum leaps in display technology could also bring hyper-realistic visuals and immersive holographic experiences that defy current limitations. However, as we embrace this quantum future, the importance of global collaboration and ethical frameworks will become paramount. The development of quantum technologies is a global endeavor, and establishing international standards for their safe and responsible deployment will be crucial. Discussions around the potential for dual-use technologies, those with both benevolent and malicious applications, will intensify. Ensuring equitable access to quantum education and resources will be vital to prevent a widening of the technological divide between nations and to ensure that the benefits of this revolution are shared by all. By 2035, the world won't just be using quantum technology, it will be thinking quantum. The fundamental principles that once seemed confined to the abstract realm of physics will have permeated our understanding of the world, inspiring new ways of solving problems, innovating, and interacting. The future, in essence, will be a living testament to the profound and often counterintuitive beauty of the quantum universe. The year is 2035, and the quantum revolution, far from a distant scientific dream, is now an undeniable force shaping our world. Its influence extends even to the most fundamental aspects of society, subtly redefining our capabilities and interactions. The very act of scientific discovery will accelerate dramatically. Quantum simulation capabilities, now more mature and accessible, are allowing scientists to model phenomena that were previously intractable. Imagine simulating the precise behavior of complex proteins for new drug designs, or predicting the properties of novel materials before a single atom is synthesized. This will dramatically reduce the time and cost of research and development across disciplines, from pharmaceuticals to aerospace engineering. Furthermore, the integration of quantum machine learning with large scientific datasets will uncover hidden correlations and patterns, leading to serendipitous discoveries that would be impossible through traditional methods. We will see faster breakthroughs in areas like fusion energy research, as quantum models better predict plasma behavior, bringing us closer to a clean, abundant power source. While the threat of quantum computing breaking current encryption methods is real, the decade will also witness the widespread adoption of post-quantum cryptography, PQC. Governments, financial institutions, and critical infrastructure will have largely transitioned to new cryptographic standards designed to withstand quantum attacks. More excitingly, rudimentary quantum internet nodes will be established, offering truly unhackable communication channels for sensitive data exchange. This isn't just about protecting secrets, it's about building a fundamentally more secure global information network where privacy is guaranteed at the quantum level, significantly enhancing trust in digital interactions. Beyond the grand scientific and technological shifts, quantum mechanics will subtly weave its way into our everyday experiences. Your next-generation smartphone might incorporate a quantum sensor for unprecedented environmental monitoring, detecting airborne pollutants or even early signs of illness with astonishing accuracy. Personal navigation systems in autonomous vehicles will leverage quantum inertial sensors for pinpoint accuracy, ensuring safer and more reliable transportation even in GPS-denied environments. Even in areas like personalized education, quantum-inspired algorithms will analyze vast amounts of student data to create hyper-tailored learning paths, optimizing knowledge acquisition and skill development in ways never before possible. The pervasive influence of quantum physics by 2035 won't be a sudden, jarring change, but rather a gradual, inevitable integration into the very fabric of our technological and scientific endeavors. We'll be living in a world that is more precise, more secure, and infinitely more capable, all thanks to the strange and wonderful rules of the quantum universe. By 2035, the quantum revolution won't just be about advanced technology, it will begin to reshape our very understanding of resource management and sustainability. Imagine quantum sensors embedded deep within the Earth, providing unparalleled insights into geological formations, optimizing the extraction of critical minerals with minimal environmental impact, and even detecting early warning signs of seismic activity with unprecedented accuracy. This hyper-precise data will allow for more sustainable resource allocation, reducing waste and mitigating the ecological footprint of industrial processes. The challenge of clean energy will also see significant breakthroughs driven by quantum science. Beyond more efficient solar cells and batteries, quantum computing will accelerate the discovery and design of novel catalysts for processes like carbon capture and hydrogen production, making these technologies economically viable on a global scale. We might even see the advent of truly efficient quantum-enhanced fusion reactors, moving closer to a future of abundant, clean energy that doesn't rely on finite fossil fuels. The ability to simulate complex quantum interactions within energy systems will be the key to unlocking these next-generation solutions. The shift won't be without its profound societal and ethical considerations. As quantum technologies empower unparalleled surveillance capabilities, discussions around privacy and individual freedoms will intensify. The potential for quantum-enhanced AI to automate complex decision-making processes will raise questions about accountability and human oversight. A global dialogue will be essential to establish ethical guidelines and regulatory frameworks that ensure these powerful tools are used responsibly and for the benefit of all humanity, not just a select few. Furthermore, the demand for quantum talent will skyrocket. Educational systems worldwide will be rapidly adapting, integrating quantum literacy into curricula from an early age. New interdisciplinary fields will emerge, blending quantum physics with biology, engineering, and even the social sciences, fostering a generation of innovators ready to navigate and shape this new quantum era. In essence, by 2035, the world will be living on the cusp of a truly quantum age. It won't be a future of flying cars or teleportation, at least not yet, but one where the fundamental fabric of reality, as described by quantum mechanics, is harnessed to build a more efficient, secure, and insightful world. We'll be solving problems once thought insurmountable, and perceiving the universe with a clarity previously unimaginable, all thanks to the strange and beautiful dance of particles at their smallest scales. By 2035, the quantum wave won't just be a technological shift, it will begin to influence the very fabric of our global geopolitical landscape and national security. The race for quantum supremacy, already underway, will intensify, with nations vying for leadership in quantum computing, communication, and sensing. This competition will drive significant investments in research and development, but also necessitate new international agreements and treaties to manage the ethical implications and potential dual-use nature of these powerful technologies. Quantum cyber warfare, while still in its infancy, will be a growing concern, pushing countries to fortify their digital defenses with quantum-resistant encryption. National defense systems will see a profound transformation. Quantum-enhanced radar systems will offer unprecedented detection capabilities, identifying stealth aircraft and missiles with higher precision and at greater distances. Quantum navigation systems will provide impervious positioning for military assets, resilient to jamming or spoofing. The ability to simulate complex battle scenarios and optimize strategic decisions using quantum algorithms will give militaries a significant advantage, potentially reshaping the very nature of conflict and deterrence. Economically, the quantum revolution will spur the creation of entirely new industries and the significant restructuring of existing ones. We'll see the emergence of quantum-as-a-service, QaaS, providers, offering cloud-based access to quantum computing power for a wide range of enterprises. This will democratize access to quantum capabilities, allowing smaller businesses and startups to innovate in ways previously reserved for large corporations. The demand for quantum-safe hardware and software will create a booming market, driving investment and job growth in specialized manufacturing and cybersecurity sectors. Countries that invest heavily in quantum education and infrastructure will likely become economic powerhouses in this new era. The influence of quantum physics by 2035 will extend beyond the laboratory and into the complex web of international relations, economic competition, and societal resilience. It will demand new ways of thinking about security, prosperity, and collaboration, as humanity grapples with the immense power and profound implications of controlling matter at its most fundamental level. The journey into the quantum age is not just about scientific discovery, it's about a fundamental redefinition of our world. By 2035, the influence of quantum physics will also profoundly impact the very nature of education and human potential. The traditional silos of knowledge will begin to crumble as quantum principles become foundational across scientific and engineering disciplines. Universities and research institutions will increasingly offer interdisciplinary programs, fostering a generation of quantum-native thinkers who intuitively grasp the nuances of this new paradigm. This will not only accelerate scientific discovery but also cultivate a workforce equipped for the jobs of the future, many of which don't even exist yet. Imagine quantum-enhanced educational platforms that adapt in real time to a student's cognitive state, optimizing learning pathways based on their individual brain activity and engagement levels. This could revolutionize personalized learning, making education more accessible and effective for diverse learners. Furthermore, the ability of quantum computers to explore vast solution spaces and generate novel ideas could even assist in creative processes. Artists, designers, and musicians might leverage quantum algorithms to generate unique compositions, visual art, or architectural designs, pushing the boundaries of human creativity in unprecedented ways. Beyond the practical applications, the pervasive understanding of quantum mechanics will continue to challenge and expand our philosophical perspectives on reality itself. Concepts like superposition, entanglement, and the observer effect will move further into public discourse, prompting deeper reflection on the nature of consciousness, free will, and the very fabric of existence. This intellectual engagement with the quantum world will inspire new schools of thought and artistic movements, enriching our cultural landscape in profound ways. In essence, by 2035, quantum physics will have transcended its role as a purely scientific discipline to become a fundamental lens through which we understand and interact with the world. It will not only power our advanced technologies but also inform our educational systems, shape our societal values, and expand the very limits of human imagination. The future, in every sense, will be steeped in the strange and beautiful logic of the quantum realm. By 2035, the pervasive influence of quantum physics will have even started to subtly redefine urban infrastructure and smart living. Imagine cities where traffic lights dynamically optimize flow based on real-time data gathered by ultra-sensitive quantum sensors, drastically reducing congestion and pollution. Buildings could integrate quantum materials that dynamically adjust their thermal properties, leading to unprecedented energy efficiency and a significantly reduced carbon footprint for urban centers. Waste management systems might leverage quantum-enhanced analytics to optimize collection routes and recycling processes, pushing cities closer to true sustainability. The impact on healthcare delivery will be profound. Beyond drug discovery, quantum sensors could lead to highly miniaturized and non-invasive diagnostic devices capable of detecting diseases at their earliest, most treatable stages, even at the cellular level. This could usher in an era of truly preventative and personalized medicine. Imagine point-of-care devices that leverage quantum principles to analyze biomarkers with unheard-of precision, providing immediate and accurate diagnoses without the need for extensive lab work. Furthermore, quantum computing could accelerate the development of sophisticated AI for medical imaging, making diagnoses faster and more reliable than ever before. Even the realms of art and design will feel the quantum tremor. Artists might explore new mediums, using quantum phenomena to create dynamic, interactive installations that respond to the viewer's presence in novel ways. Designers could leverage quantum simulation to create materials with aesthetic and functional properties previously considered impossible, leading to a new generation of products that are both beautiful and supremely efficient. The very act of creation could be augmented by quantum-inspired algorithms that generate novel patterns, textures, and forms, pushing the boundaries of human imagination. The pervasive nature of quantum physics by 2035 will mean that its influence is felt in virtually every facet of life. It won't be a niche scientific pursuit but a fundamental pillar supporting and shaping our advanced societies. The world will be more interconnected, more efficient, and more profoundly understood, all through the lens of the strange and beautiful quantum realm. By 2035, the deep, pervasive influence of quantum physics will extend its reach even to the very concept of human-computer interaction and artificial intelligence itself. We might see the emergence of quantum interfaces that go beyond touchscreens and voice commands, allowing for more intuitive and perhaps even thought-driven control of devices. Imagine interacting with your digital world through subtle neural signals, made possible by quantum-enhanced brain-computer interfaces that interpret complex brain patterns with unprecedented accuracy. This could revolutionize accessibility, entertainment, and professional productivity. The advancements in quantum computing will also critically impact the development of more ethical and explainable AI. Current black box AI models often make decisions without clear justification. Quantum machine learning, with its ability to process vast datasets and discern complex relationships in fundamentally different ways, could pave the path for AI systems that are not only more powerful but also more transparent and auditable. This would be crucial for building trust in AI applications within critical sectors like healthcare, finance, and legal systems. We could see the emergence of AI that can articulate why it made a certain decision, a significant step towards truly intelligent and responsible machines. The precision offered by quantum sensors will unlock entirely new frontiers in remote sensing and imaging. Consider space exploration. Quantum magnetometers could analyze planetary magnetic fields with exquisite detail, revealing hidden geological structures or subsurface water sources. In everyday life, miniature quantum imaging devices could allow for non-invasive medical scans that provide real-time, high-resolution views of internal organs, or security scanners that can detect contraband with perfect accuracy without physical contact. The ability to see beyond conventional limits will redefine what's detectable and measurable. Ultimately, by 2035, quantum physics will have evolved from an abstract scientific discipline to an indispensable engineering tool, fundamentally interwoven with the fabric of our advanced societies. It will not only empower our technologies but also challenge our understanding of intelligence, reality, and what it means to be human in an increasingly quantum world. The journey into this quantum age is not just about technological advancement, but a profound transformation of our global civilization. By 2035, the deep, transformative influence of quantum physics will extend even to the realm of personal well-being and augmented human capabilities. Imagine compact, wearable quantum sensors that continuously monitor your vital signs, not just for basic health metrics, but for subtle quantum-level biomarkers indicative of disease onset years before symptoms appear. These devices could provide hyper-personalized health insights and proactive interventions, ushering in an era of truly predictive and preventive medicine, allowing individuals to optimize their health and longevity in unprecedented ways. Beyond medical diagnostics, quantum technologies could even begin to augment human senses. While direct neural interfaces are still a distant dream, consider prosthetic devices or sensory aids that leverage quantum precision to offer enhanced vision, hearing, or even tactile feedback. This could open up entirely new avenues for accessibility, allowing individuals with sensory impairments to experience the world with a richness and detail previously unimaginable. The subtle manipulation of quantum states could lead to interfaces that translate environmental data into intuitive sensory inputs, expanding the very definition of human perception. The advent of quantum materials will also trickle down to consumer products, leading to a new generation of personal items. Think of clothing made from quantum-engineered fibers that are self-cleaning, hyper-regulating temperature, or even capable of generating small amounts of electricity from ambient energy. Personal devices, from smartphones to smart home appliances, could become vastly more efficient, durable, and powerful due to quantum-optimized components, requiring less frequent charging and offering richer, more responsive user experiences. In a world increasingly reliant on digital interactions, quantum-safe digital identity will become paramount. While blockchain technology provides robust distributed ledgers, quantum cryptography will offer the ultimate layer of security for personal data and transactions. Your digital identity, from financial records to medical history, will be secured by protocols fundamentally immune to the computational power of even the most advanced quantum computers, fostering an unprecedented level of trust and privacy in the digital realm. Ultimately, by 2035, quantum physics will have permeated far beyond the confines of research labs and specialized industries, deeply impacting our daily lives and expanding the very definition of human potential and well-being. It will empower us with new ways to understand our bodies, interact with our environment, and secure our personal information, all thanks to the remarkable and often counterintuitive properties of the quantum world. The future, in its most intimate details, will be undeniably quantum. By 2035, the deep, transformative influence of quantum physics will have permeated far beyond the realm of technology and even into the more subtle aspects of resource management and the global economy. The ability to simulate complex molecular interactions with unprecedented accuracy will revolutionize catalysis, leading to breakthroughs in industrial processes that dramatically reduce energy consumption and waste. Imagine factories that run with significantly less power, or chemical reactions that yield perfect products with no harmful byproducts, thanks to quantum-optimized pathways. This will have a profound impact on manufacturing efficiency and environmental sustainability worldwide. Even agriculture will feel the quantum shift. Quantum sensors could be deployed to precisely monitor soil health, nutrient levels, and even plant stress at a microscopic level, allowing farmers to optimize irrigation and fertilization with unparalleled efficiency. This hyper-precise approach, often termed precision agriculture, will lead to higher yields with less resource depletion, addressing global food security challenges in a more sustainable manner. Quantum simulations might even accelerate the development of new crop varieties resistant to climate change or pests, by modeling complex genetic interactions. The quantum revolution will also foster a new era of scientific collaboration and open science. As quantum computing resources become more widely accessible via cloud platforms, researchers from diverse geographical locations will be able to collaborate on complex problems, sharing computational power and experimental data in unprecedented ways. This global scientific network, underpinned by quantum-secure communication, will accelerate the pace of discovery across all fields, fostering a truly interconnected and collaborative scientific community. The ability to verify and secure data at a quantum level will also enhance trust in shared research, accelerating the move towards more open and reproducible science. In essence, by 2035, quantum physics will no longer be a futuristic concept but a tangible, integrated force shaping our world's most critical systems. It will drive efficiency, unlock new resources, and foster a more collaborative and sustainable future, all by harnessing the fundamental, often counterintuitive, rules that govern the universe at its smallest scales. By 2035, the pervasive influence of quantum physics will have seamlessly integrated into our daily lives, often in ways we don't consciously perceive, yet profoundly impacting everything from our personal devices to global infrastructure. Consider the ubiquitous smart city of 2035. Its intelligence will be underpinned by a network of quantum sensors meticulously monitoring every aspect of urban life. Traffic management systems will not only adapt to real-time flow but predict congestion hours in advance based on subtle quantum fluctuations in vehicle emissions or pedestrian movements. Smart grids will leverage quantum optimization algorithms to dynamically balance energy supply and demand, drawing seamlessly from diverse renewable sources and minimizing waste, making blackouts a distant memory. Buildings will possess quantum skins that react to external conditions, optimizing natural light, temperature, and air quality with unprecedented efficiency, creating healthier and more sustainable living environments. Even the realm of entertainment and immersive experiences will undergo a quantum transformation. While a full quantum metaverse might still be a vision, 2035 will see the first steps towards hyperrealistic virtual realities and augmented realities powered by quantum-inspired rendering and data processing. Imagine interactive narratives that adapt to your every micro-expression, or virtual environments that are indistinguishable from physical reality, created by algorithms capable of simulating light and sound at a fundamental quantum level. This could revolutionize gaming, remote collaboration, and even therapeutic applications, allowing for truly immersive and personalized experiences. Perhaps one of the most profound, albeit still nascent, areas of impact will be in neuroscience and the understanding of the human brain. While a full quantum consciousness theory is highly speculative, quantum-enhanced brain imaging techniques will allow neuroscientists to map neural pathways and observe brain activity with a resolution and sensitivity previously unimaginable. This could unlock fundamental secrets about memory, learning, and even consciousness itself, leading to revolutionary treatments for neurological disorders and a deeper appreciation for the complex quantum dance within our own minds. In essence, by 2035, quantum physics will be less of a scientific marvel and more of a foundational utility, quietly powering the next generation of technologies that define our modern world. It will enable a future that is not just more connected and efficient, but also more intelligent, more sustainable, and ultimately, more aligned with the subtle yet profound rules that govern the universe at its most fundamental level. The quantum future is not just coming, it is already beginning to unfold around us. By 2035, the quantum revolution will no longer be a future promise but a present reality, deeply embedded in the fabric of our world. It won't be a dramatic, sudden shift, but a pervasive transformation, quietly enhancing nearly every aspect of our lives. The ubiquitous nature of quantum sensors will redefine our interaction with the environment, offering unparalleled precision in everything from personalized health monitoring to climate data collection. Our digital lives will be safeguarded by quantum cryptography, rendering current threats obsolete and ushering in an era of unprecedented data security. While general-purpose quantum computers might not be in every home, their powerful capabilities will be accessible via the cloud, serving as indispensable accelerators for complex simulations in medicine, materials science, and AI development, unlocking solutions to problems once thought intractable. The influence will stretch beyond technology. Our very understanding of the universe, from the subatomic to the cosmological, will deepen, driven by quantum insights. Education will evolve, fostering a new generation fluent in quantum principles, ready to explore previously unimagined scientific and technological frontiers. The ethical considerations surrounding these powerful tools will mature, guiding their responsible development and ensuring that the benefits of this revolution are shared globally. In essence, by 2035, we'll be living in a world that is fundamentally more precise, more secure, and more intelligent, all thanks to the strange and beautiful rules of the quantum realm. The future isn't just digital, it's profoundly quantum.